Hello guys! Welcome sa ating z-knowledgeTV. Okay, so for the lesson 6, so ang pag-aaral natin is about cells and batteries. So for the objective, so after successful completion of this unit, you should be able to recognize the characteristics of cells and batteries and their effects in simple circuits. So, lahat ng ito ay pag-aaralan natin dito sa ating tutorial. Pero, before tayo mag-start, don't forget to like this video and click the subscribe button para ma-notify kayo sa mga next videos. So, let's get started. Okay? So, for the cell, so, ito ba yung pag-aaral natin? So, syempre, hindi human cell ang pag-aaral natin, kundi itong figure na ito. Okay, so ang tawag dito is cell. So, hindi yan battery. Ang tawag dyan, cell. So, kapag sinamahan natin siya o kinonektahan natin siya ng another cell, so, doon pa lang natin masasabi o matatawag na battery. Okay? So, siguro ganito yung itsura nyo, no? So, mapa-amazing kayo. At papatanong, how did this happen? So, paano nga ba nangyari yon? Na kapag pinagsama yung dalawang cell, is magiging battery. So, pag-aral natin siya. Okay, so first, let's discuss about the cell terminology. So, natin ang anode. So, anode is the destination of electrons or dun siya papunta, yung mga electrons natin. Then, yung cathode is the source of electrons o dun yung nanggagaling yung mga electrons natin. Then, ions is an atom with an imbalance of electrons. Then, irreversible, once the cell runs out of juice, it is dead. Reversible, able to run the cell backwards. Rechargeable, the cell be run backwards by the application of electricity. Then yung shelf life, the period the cell may be stored and still be usable. Then electrochemical action, the process of converting chemical energy into electrical energy. Polarization, the effect of hydrogen surrounding the anode of a cell which increases the internal resistance of the cell. Then yung local action is the continuation of current flow within the cell when there is no external load. Then yung electrolyte is the solution that acts upon the electrodes. The electrolyte, which provides a path for electron flow, may be a salt, an acid, or an alkaline solution. And then yung electrolysis, using electricity to decompose substances. And yung electroplating is the coating a substance with another substance. Okay? So, for the chemical cell, a chemical cell is defined as a device that generates electricity by converting chemical energy to electrical energy. So, yun yung chemical cell. So, as a chemical energy is converted to electrical energy. So, by chemical action in a cell, thus electricity is produced. Okay? So, parang ganito. So, itong figure natin, so, isa siyang cell na kung saan yung mga chemical na meron tayo, siya yung nagde-define, yung nagko-convert papuntang electrical energy. Okay, so let's talk about the cell. So a cell consists of electrodes and electrolyte. So when the electrodes are immersed into electrolyte or binabad natin, so the chemical action between them generates electricity. So parang ganito. So nilagay natin yung dalawang electrode natin sa electrolyte natin. So meron tayong chemical na nagti-trigger dyan. Okay? Na kung saan, magkakaroon tayo ng electricity. Okay, so electrodes are conductors by which electrons leave or return to a cell. So the material an electrode is made of makes it either positive or negative. So electrolyte is a dilute solution of acid or alkali and may be either liquid or a moist phase. Electrolyte is the conductor of electrons from electrode to electrode within the cell. Okay? So, the chemical action in a primary cell usually erodes the negative electrode. As this takes place, the composition of the electrolyte is changed and it becomes unusable. So, yung primary cell cannot be recharged. So, yun yung tatanda natin. So, it can be restored by replacing the eroded electrode and the electrolyte. So, doon pa lang natin ma-restore yung energy na meron sa primary cell. So, an example of a primary cell is shown in the figure. Okay? So, meron tayong tinatawag na dalawang electrode, yung zinc saka yung copper. So, the electrodes are made of zinc and copper. So, the zinc electrode is the negative electrode or cathode ng cell. So, the copper electrode, siya naman yung positive electrode natin or yung tinatawag natin na anode sa cell. So, the electrolyte of the cell is an alkaline solution. Okay? So, take note ha. Yung sa zinc natin, since siya yung sa cathode, so siya yung pinanggagalingan o pinagmumulat ng electrons natin. And then yung copper, siya yung positive electrode. So, siya yung anode. So, siya yung pinupuntahan ng mga electrons natin or the destination ng electrons. So, another example of a primary cell is shown below. So, meron tayong zinc sa carbon. So, this cell has a positive electrode that is made of carbon and the negative electrode made of zinc. So, the zinc electrode is also the container for the other parts of the cell. So, the electrolyte is a moist phase that contains the chemicals necessary to generate electricity as a chemical action takes place between it and the electrode. Okay? So, ito yung mga different examples o types ng mga primary cell natin. So, meron tayong primary dry cell, mercuric oxide zinc cell, manganese dioxide alkaline zinc cell, magnesium manganese dioxide cell, lithium organic cell, and lithium inorganic cell. Tandaan natin na lahat ng types ng cell na to, ng primary cell na to, is non-rechargeable. So, hindi sila nagre-recharge. Pwede silang ma-restore so, by replacing yung mga electrodes natin. Okay. So, the chemical action that takes place in a secondary cell as it generates electricity causes the materials that make up the electrodes to be transferred from one electrode to the other. So, a secondary cell can be charged or recharged. So, ito naman yung pwede. By forcing a current through it in a direction that is opposite the direction of current flow during discharge. So, when a secondary cell is recharged, the materials that were transferred from one electrode to the other change back to the original materials that were used to make the cell. So, the chemical action that takes place in a secondary cell affects both the electrode material and the composition of a liquid electrolyte, as shown below. Okay? So, kapag charge yung cell natin, so, ganito yung itsura ng loob niya. Okay? So, kapag nag-discharge siya, so, papansin natin na yung sponge lead niya is nagde-decrease. Then, yung lead sulfate niya is increasing naman. So, maging naman sa kabilang electrode, na kung saan yung lead peroxide natin is nag-decrease, then yung lead sulfate is nag-increase. So, ganun nangyari kapag discharging. So, kapag nag-charging ulit siya, okay, so mangyari, yung sponge lead natin is increasing. So, kabaliktaran na. Then, yung lead sulfate is magbabawas. So, decreasing na. Then, sa kabilang electrode natin, yung lead peroxide natin is increasing. Then, yung lead sulfate is decreasing naman. So, kapag magdi-discharge na siya, so yung sponge lead natin is mapupunta sa minimum at yung lead sulfate natin is magiging maximum. Then, sa kabilang electrode natin, yung lead peroxide is going minimum. Then, yung lead sulfate is papunta siya sa maximum. Tandaan natin, yung ganitong electrode, yung itsura ng electrode, siya yung sponge lead. Tapos yung medyo clear, siya yung lead peroxide. Then yung may part ng parang dark, so siya yung lead sulfate. Okay? So the transfer of materials in the cell above causes the sponge lead and lead peroxide to change to lead sulfate. So yung drawing D, which is yung discharge, shows a generator being used to force current through the cell in a direction opposite to the direction of current in drawing B. So therefore, the generator is charging the cell. So the electrolyte in drawing C is mostly water or H2O. So basta tanda natin, kapag nag-connect tayo ng load dun sa cell natin, so automatic na magdi-discharge yan. Kasi nagkaroon ng connection yung dalawang electrode natin. And then kapag naman kinonektahan mo naman ng power supply, yung power source, so mag-charge din yan. Okay? So, an example of secondary cell is shown in the drawings below. So, ito yung isang example ng secondary cell. And then, yung positive electrode daw dito is made up of the positive plate group. And the negative electrode, siya yung negative plate group. Okay? Then, ito yung mga different types ng secondary cell. So, meron tayong lithium cell, sealed lead acid cell, nickel metal hydride, and nickel cadmium cell. So, lahat sila is may equivalent na voltages. Okay. So, the positive plate group makes up the positive electrode. So, the negative plate groups makes up the negative electrodes. So, placing the assembled cell in a container of electrolyte will cause a chemical action that will generate electricity. So, a secondary cell differs from a primary cell in that a secondary cell can be recharged and a primary cell can only be restored. So, yun yung difference ng primary at secondary cell. So, the factors that affect the voltage rating of a cell are the material the electrodes are made of and the composition of the electrolyte. So, yung voltage rating of a cell that has a dilute solution of ammonium chloride o sal ammoniac for its electrolyte and electrodes made of carbon and zinc is 1.5 volts yung equivalent na voltage rating. So the factors that affect the current capacity naman ng cell are the size of the electrodes. So the distance between them in a solution of electrolyte and the temperature, syempre. So, yung current capacity ng cell is expressed in ampere hours. So, yung ampere hours of a cell is the measurement of current capacity that indicates the amount of current that will flow through a circuit in a certain amount of time. So, the ampere hours or current capacity of a cell is affected by the size of the electrodes, distance between the electrodes, and in the electrolyte, and the temperature. So when current flows through a cell, it causes gas bubbles to form and some of them accumulate on the positive electrode. So the accumulation of gas bubbles tends to reverse the polarity of the cell, thus increasing the effective resistance of the cell. So this reduces the current flow and lowers the voltage available at the cell terminals. So as the result, the result of the chemical reaction that causes the accumulation of gas bubbles on the positive electrode of a cell is called polarization. So the impurities in the materials used to make electrodes and electrolyte cause a chemical action to take place in a cell when the circuit is open. So this chemical action will discharge a cell when it is not supplying power to a circuit. So the chemical action of an open circuit cell that takes place because of the impurities in the materials used to make electrodes. An electrolyte causes local action which will discharge the cell. So when a lead acid cell is being discharged, a chemical reaction takes place that causes the sulfuric acid in the electrolyte to combine with the lead plates, which forms lead sulfate. So the formation of lead sulfate coats the electrodes with lead sulfate and decreases the acid content of the electrolyte. So yung result naman nun ng chemical reaction is called the lead sulfation. Okay? So that's the concept of creation o pag-generate ng cell. Okay? So for the battery, so a battery is a device which converts chemical energy into electrical energy and is made up of a number of cells. So marami ang combination ng mga cells ang battery. So batteries consist of two or more voltaic cells that are connected in series to provide a steady DC voltage at the battery's output terminals. So a battery's voltage output and current rating are determined by the elements used for the electrodes. So the size of the electrodes and the type of electrolyte used. So whether a battery may be recharged or not depends on the cells used to make up the battery. So if a battery of an open circuit voltage or VB has a loaded voltage VL when supplying load current IL, so the battery internal resistance RB is uh, this equation. RB is equal to VB minus VL over IL. So the load voltage VL and the load current IL for a load resistance are, so VL is equal to ILRL or equivalent siya sa VB minus ILRB or equivalent din siya sa VB RL over RB plus RL. Or, yung IL naman natin, equivalent siya sa VL over RL or VB minus VL over RB or equivalent din naman siya sa VB over RB plus RL. So, the battery's short circuit current ISC is VB over RB or equivalent naman siya sa VBIL over VB minus VL. So the examples below show how the method of connecting cells to form a battery will determine the terminal voltage. So for figure A, so para makapag-create tayo ng battery from different cells, yung figure A, pinapakita nito na merong 1.5 volt cells connected in series. So kung connected siya sa series, the terminal voltage of the battery is 6 volts. So, paano nangyari yun? So, need lang natin pag-addin lahat ng voltages. Okay? Voltage rating meron ang bawat cell. So, meron tayong 1.5 sa first cell, 1.5 sa second cell, 1.5 sa third cell, and 1.5 sa fourth cell. So, by getting the sum of those voltage ratings, sumakuha tayo ng 6 volts. Okay? So, for figure B, kapag connected naman sila sa parallel, so, yung figure B, pinapakita na may tatlong 1.5 volt cells tayo na connected sa parallel. So, yung terminal voltage ng battery natin is the same as 1.5 volts lang. Okay? So, sabi natin na kapag parallel sila, lahat ng voltages nila or yung magiging terminal voltage natin is pares lang sa voltage rating ng bawat cell natin. Next. So, the method of connecting cells to form a battery will determine the terminal voltage and current capacity of the battery. So, for the series connection of cells means that the negative electrode of one cell is connected sa positive electrode ng another cell or ng next cell. So, when cells are connected using this method, you can determine the terminal voltage of the battery by adding the cell voltages together. So, the current capacity of a battery of series connected cells is the same as the current capacity ng one cell. Okay? So, pare-pares naman sila ng current capacity pag in series connected cells. So, katulad nito, figure A. So, the symbol for cell is ganito. So, yung short line is the negative side of the cell and the long line is the positive side. Okay? And then, kapag pinagsama mo yung dalawang cell, so battery ang magiging equivalent nun. So, when cells are connected in series to form a battery as shown above, the cell voltages, so ganito, and so the cell voltages are added together to determine terminal voltage. So, yung current capacity is the same as the capacity of one cell. So, example, so each cell of the battery as shown in figure A is rated at 2 volts and 2 ampere hours, and they are connected in series. So therefore, yung battery has a terminal voltage of 8 volts. So bakit? Kasi kung ang rating ng bawat isang cell is 2 volts, then connected sila sa series, so pag-addin lang natin yan. Or i-multiply natin yung 2 volts times 4. Kasi pare-pares sila na 2 volts. Okay, so makakuha tayo ng 8 volts. And then yung current capacity nila, since na they are in series, so pare-pares lang yan. So kung meron kang current capacity to kay cell 1 na 2 ampere hour, so dapat meron ka rin dapat 2 rito, 2 rito, at 2 rito. And then yung total current capacity mo is pares na 2. Okay, so next, the terminal voltage of a battery that has 6 cells, each rated at 2 volts and 1 ampere hour connected in series. So, yung battery will be 12 volts. Okay? And the current capacity will be 1 ampere hour lang din. Okay, so bakit naging 12 volts? Kasi meron ka ng 6 na cells. At each cell is merong 2 volts. So kapag pinag-multiply mo yan, o pinag-add mo yung lahat ng cells mo, so meron kang 12 volts. And same pa rin, since na they are in series, so pare-parehas yung current capacity. So next, for parallel connection. So parallel connection of cell means that the negative electrode of one cell is connected to the negative electrode of the next cell, and the positive electrode of one cell is connected to the positive electrode of the next other cell. So when cells are connected using this method, you can determine the current capacities of the cells together. So the terminal voltage of a battery of parallel connected cells is the same as the terminal voltage of one cell. So parang katulad nitong figure B. Okay? So the terminal voltage of the battery as shown in figure B is 1.5 volts. Bakit 1.5? Kasi sa kapag yung mga cells natin is connected in parallel, pare-pares lang yung magiging voltage rating niyan. Okay? Pero sa current capacity, mag-add yun. Okay? So, kung sa cell 1 ka, meron kang 1 ampere hour. Sa cell 2, meron ka rin 1 ampere hour. So, cell 3, meron kang 1 ampere. So, kunin natin yung sum ng tatlong yon. So, ayun yung magiging current capacity ng battery natin. So, magiging 4.5 ampere hours yun. Okay? So, take note na you can obtain maximum terminal voltage by connecting cells in series. And also, you can obtain maximum current naman, current capacity, by connecting cells in parallel. So, depende sa inyo kung ano yung gusto nyo makuha. Kung need nyo ng maximum terminal voltage, so dapat pag-connect-connectahin nyo lahat ng cells nyo in series. Kung gusto nyo naman ng maximum current capacity, pag-connectahin nyo lahat ng cells nyo in parallel. Okay, so for battery charging, the following types of charges may be given to a storage battery. So depending upon the condition of the battery. So kapag initial charge, so when a new battery is shipped dry, the plates are in an uncharged condition. So after the electrolyte has been added, it is necessary to charge the battery. This is accomplished by giving the battery as a long low rate initial charge. Okay? So kapag normal charge is a routine charge that is given in accordance with the nameplate data during the ordinary cycle of operation to restore the battery to its charge condition. Okay? So, equalizing charge. An equalizing charge is a special extended normal charge that is given periodically to batteries as part of maintenance routine. It ensures that all the sulfates driven from the plates and that all the cells are restored to maximum specific gravity. So, the equalizing charge is continued until the specific gravity of all cells connected for temperature shows no change for a 4-hour period. And then yung floating charge, the charging rate is determined by the battery voltage rather than by a definite current value. So the floating charge is used to keep a battery at full charge while the battery is idle or in light duty. It is sometimes referred to as a trickle charge and is accomplished with low current. And last, for the fast charge. A fast charge is used when a battery must be recharged in the shortest possible time. So the charge starts at a much higher rate than is normally used for charging. It should be used only in an emergency as this type of charge may be harmful to the battery. Okay? Pero kung meron namang mga battery na nakadesign na fast charging, so hindi naman ganun magiging harmful siya sa battery. Kasi nakadesign na siya as fast charging. Okay? So, let's proceed sa example 3. So, the terminal voltage and current capacity of a battery of cells connected in a combination of series parallel may be determined as shown below. Okay, so dito, meron tayong mga cell. Okay, so each cell daw, okay, so meron tayong 8 cells. E1, E2, E3, hanggang E8. So, bawat isang yan is merong daw 1.5 volts at 1 ampere hour. Okay, so para makuha natin yung terminal voltage o yung pinaka-voltahe natin dito, okay, so ano kaya yung voltage natin dyan? Sabi natin V out. So, gawin natin, kunin natin yung series combination na to. So, kung ang E1 mo is 1.5, E2 mo is 1.5, so pag kinuha natin yung series nila, magiging 3 volts yan. Okay? And tignan mo na yung lahat ng bawat cell mo is in parallel. Okay, di ba? Pare-pares na 1.5 naman yan. So therefore, lahat yan is meron kang 3 volts, 3 volts, at 3 volts. So kung pare-pares silang 3 volts at lahat sila is connected in parallel, so therefore, ang Vout mo ay 3 volts. Okay? So ano naman yung current capacity mo? So ang current capacity mo, So, kapag series, okay, di ba, pag series, equal lang ang current capacity. So, current capacity dito sa E1 equal lang sa current capacity ng E2. So, therefore, kapag ang nakaseries sila, meron kang current dyan na 1 ampere hour lang. Okay? Kaya lang, since na they are in parallel, so sabi natin meron ka din ditong 1 ampere hour, 1 ampere hour, 1 ampere hour sa bawat pair ng cells mo. So, kapag since na they are in parallel connection, so pag-aadin mo lahat ng current capacity. So, therefore, since meron kang apat na combinations, so therefore, meron kang current capacity na 4 ampere hours. Okay? So, ganyan kung paano natin i-solve o makuha yung terminal voltage at current capacity ng isang battery. Okay? So, that's the end of this presentation. So, thank you for watching. Thank you for listening.